For example, if we're asked to find the highest common factor of 18 and 30, we'll start by listing factors of 18 factors of 30, and then we can use our answers to find the largest of the common factor. So we'll use the factors of 18 and factors of 30 to find the largest common factor. To find factors of 18, think of pairs of numbers that multiply to give you 18. For example, 1 multiplied by 18 is 18. 2 multiplied by 9 is 18. 3 multiplied by 6 is 18. So we can say that the factors of 18 are 1, 2, 3, 6, 9, and 18. The same way we can find factors of 30 by thinking of pairs of numbers that multiply to give 30. For example, 1 multiplied by 30 is 30. 2 multiplied by 15 is 30. 6 multiplied by 5 is 30. And 10 multiplied by 3 is 30. So factors of 30 will be 1, 2, 3, 5, 6, 10, 15, and 30. Okay, so what you want to find here is the largest common factor. Now, if you look at factors of 18 and 30, the largest common factor is 6. So we'll say that the highest common factor of 18 and 30 is 6. Now, this method works for small numbers, but when you have big numbers, we have to use an alternative method. For example, find the highest common factor of 84 and 120. Now what we'll have to do here is we'll have to use the factor trees to help us. I'll start by drawing the factor tree of 84. So 84 is 2 multiplied by 42. 42 is 2 multiplied by 21. 21 is 3 multiplied by 7. And all these numbers here are prime numbers. So they are prime factors of 84. So right below here, 84 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 7. Likewise, 120 is 2 multiplied by 60, which is 2 multiplied by 30, which is 2 multiplied by 15. That's supposed to be 15, which is 3 multiplied by 5. Now, all these numbers here are prime numbers. And we can summarize that here by saying that the prime factors of 120 are 2, 2, 2, 3, and 5. Remember, our goal is to find the highest common factor. So there's an extra step that you have to do once you find you found these prime factors. We shall use a Venn diagram. So this is called a Venn diagram. a Venn diagram will help us to organize this information that we have, the prime factors of 84 and 120. So here I'll have 84, and here I'll have 120. Now, if you look at prime factors of 84 and 120, there are those prime factors that are in both 84 and 120. For example, 2 is in both, so I'll write 2 there. So that's it. There's also another pair of 2 that's in both, so 2 there, and then I have 3 here, and I write 3 there. Now, prime factors that are just in 84 is just 1, which is 7. Use a different color for that. Just like that. So here it's 7. And prime factors that are just in 120 is 2 and 5. So if we want to find the highest common factor, of course, the word common, what is in common? What prime factors are in common both in 84 and 120? We have them here, 2, 2, and 3. So the highest common factor of 84 and 120 will be 2 multiplied by 2 multiplied by 3. The prime factors that are in both 84 and 120, we're just multiplying them. So that will be equal to 12. Here is another example. Find the highest common factor of 30 and 180. Sorry. Find the highest common factor of 30 and 80. So I'll start with factor 3. Start with 30 on the left. 30. 2 multiplied by 15. 3 multiplied by 5. All these guys here are prime numbers. So I can say that 30 is equal to 2 multiplied by 3 multiplied by 5. For 80, we'll also do the same, use the same process. So 2 and 40, because 2 multiplied by 40 is 80. 2 multiplied by 20 is 40. And then 2 multiplied by 10 is 20. And then 2 multiplied by 5 is 10. And all these guys here are prime numbers. So summarize that here by saying that 80 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5. Just by comparing this to 2 is in both here, and also 3 is in both, not 5 is in both. So my next step is to draw a Venn diagram to represent this. This circle represents 30. Just in 30 is 3, but 2 and 5 are in both. Just in 80 we have 2, 2, and 2. So the highest common factor of 30 and 80 will be, we multiply the numbers that are in both. And those numbers are in both 30 and 80. This is 80. It's 2 and 5, so we multiply 2 and 5 to get our highest common factor, which is 10. Here is another example, just to help us understand this process of finding the highest common factor using factor trees. So I'll start with factor tree again for 96. 2 multiplied by 48 is 96. 2 multiplied by 24 is 48. 2 multiplied by 12 is 24. 2 multiplied by 6 is 12. And 2 multiplied by 3, 6. All these guys here, prime numbers. And of course, they're also factors, so we call them prime factors of 96. Likewise, 156 will have to draw a factor tree. So two numbers that multiply to get 156, not 150. 2 and 78, 2 and 39, 3 by 13, and all these numbers here are prime numbers. And you can summarize these results below here. You can say 96 is 2 multiplied by 2 multiplied by 2 multiplied by 2, 1, 2, 3, 4, 5, 2 and 3. Likewise, 156 is 2 multiplied by 2 multiplied by 3 multiplied by 13. We need to represent this information in a Venn diagram. But before we do that, let's look at what numbers are in both. We have one pair of 2, second pair of 2, and then we have 3 over here. So if I draw my Venn diagram, represent these prime factors. This is for 96, this is for 156. I have 2 pairs of 2, so I'll have 2 there, and then 3. Just in 96, I will have 2, 2, and 2. Just in 156, I will have 13. So the highest common factor of 96 and 156 will be equal to 2 multiplied by 2 multiplied by 3, which is equal to 12. Now, I'm going to look at another method on how to find the highest common factor. It's called the ladder method. Now, if you want to use the ladder method to find the highest common factor, the first step is, of course, drawing the ladder itself. So we'll start by drawing the ladder. Right there, 96 and 156. Now, think of a number, smallest prime number, or any prime number that is a factor of 96 and 156. Of course, 96 and 156 are multiples of 2. So we can start with 2. 96 divided by 2 is 48. So I'll have 48 there. 156 divided by 2 is 78. Um, 48 and 78 are multiples of 2. So I can write there 2. 48 divided by 2 is 24. So I'll have 24 here. 78 divided by 2 is 39. Now, 24 and 39 are multiples of 3. So I'll write 3 there. 24 divided by 3 is 8. 39 divided by 3 is 13. And I think that's it. We can't find any other number that is divisible by 8 and 13. So, to find the highest common factor, we will multiply these numbers on the left column. So the highest common factor will be equal to 2 multiplied by 2 multiplied by 3, which is 12. Now, if you look at the previous question that we worked, which was finding the highest common factor of 96 and 156 using 3 diagrams, we ended up with the same answer as this one. So I'll leave up to you to decide which method is easier, but of course the ladder method is much shorter. We're going to find the highest common factor of 30 and 80. The first step is to draw the ladder. After drawing the ladder, we'll put 30 and 80 there. Think of a prime number that's divisible by 30 and 80. Of course, 30 and 80 are multiples of 2. So I'll have 2 here. 30 divided by 2 is 15. 80 divided by 2 is 40. Smallest prime, or any prime that's divisible by 15 and 40, is 5. So I'll have 5 there. 15 divided by 5 is 3. 40 divided by 5 is 8. Now we don't have any other number that's divisible by 3 and 8. So our ladder will end up there. Hence our highest common factor will be 2 multiplied by 5, which is 10.